Hi everyone, we are from Group 2 of Advanced Aerospace Design Project, University of Manchester. Our team members are David, Nita, Cheng, Enatri and Nanda. We are presenting our work project about designing, building and testing of commercial glider with adjustable elevator.
Design and manufacturing process. First of all, in order to make the adjustable elevator, we cut the tail into two parts. After that, we realized that we had not enough material to connect the both sides of the elevator to the servo motor. Consequently, we have to couple both of the elevators to synchronize the movement by using U-shaped rod. During this experiment, this practical solution showed a good performance of the glider, and there is no significant effect for the position of center of gravity. Next, we connect the elevator to the servo motor by using a rod. Now, we can adjust manually the angle of the elevator by moving the arm of the servo motor. Finally, to make sure our glider is stable in pitch, the center of gravity must be in front of the center of lift. This is because when center of gravity is ahead of center of lift, the glider is stable in pitch, while center of gravity is behind the center of lift, it is unstable. For achieving the stable flight, we put extra mass on the nose.
Now we are ready to fly our glider and observe the performance. Our objectives are to achieve a successful flight in glider testing and to see the effect of changing center of gravity and elevator angle to the performances of those flights. In our experiment, we tested 3 different center of gravities with 3 different angle of elevators, and we found a trimmed flight for each case.
So, from this experiment, we learned that changes on the CG and the elevator angle affect to the flight path and the velocity of a glider. For seeing this, we need to make many trials for achieving a trimmed flight. We also verified that a stable flight in a pitch is achieved by putting the CG ahead of the center of lift. Additionally, we observed that positive reflections of the elevator give an unsuccessful flight, as the pitching moment balance is at a negative angle of attack. Finally, during all the trials, we launched the glider in a slight downward flight path direction, as we need a component of the weight to get the thrust.
Now, from this test, we obtain data to calculate some of the glider performances. The data collected are the glider mass, the time and distance of the flight, and the flight path angle. Applying fundamental equations, we obtained the velocity, the lift, the drag, and the lift-to-drag ratio. The results are presented on the following table and graphs. The parameter that has a special interest is the lift versus drag ratio, also known as glide ratio, as it is a measure of the range of the flight.
To sum up, thanks to that project, we learned to work in a team with different backgrounds members and cooperate to get successful results. We also learned technical concepts while using a practical approach. Thank you for your attention.